I could say about him, but probably I should stick to comments regarding his sailing knowledge, his years of experience, ability, and so forth. He has been a sailor for, I guess, most of his life, a very successful wind-designed racer and offshore racer. And at this point, he's been manufacturing fiberglass boats for 24 years. He's presently operating the Pearson Tillotson Corporation and manufacturing fiberglass boats of all sorts, and did build our beloved Triton. Everett?
Well, it certainly is a kind of I want to say a pleasure to be able to come before a group of Pearson boat owners and feel welcome. There was a time where you wouldn't get me in this room. I thought when Chuck asked me to come, I thought back how years have changed things. There was a time when wife and I used to take the kids and go out cruising. We'd arrive in Cuttyhunk Harbor and drop the hook, and within 5 minutes there'd be people waving from all over to come unplug the head or fix the engine or get the stove working or solve some problem or another. And it used to be quite a chore. In fact, we used to try to head off. We'd see Pearson boats coming and head the other way. But it really is a pleasure to have the opportunity to speak to a group of Triton owners. It's one of the things, as the years go by, I think you forget many of the events and things that have happened to you over the years, and you forget the early years of the boat business. Many of them, I think we're happy to forget them, but when you look back at them and are able to look back after 20 years, it's kind of fun. One of the things that I think, before we go into a little bit about the Triton, is that many people are confused as to who I am or who Pearson Yachts were or where we started or who we are today. Pearson Yachts really started back in 1953. I was a junior at Brown University, and on one spring vacation, I had a cousin. There was a cousin, Clint, and I. We grew up together in Pawtucket, Rhode Island, and we, in 1953, built a plug for an 8-foot dinghy and started molding some fiberglass boats during that summer. And that proceeded until at that time I was at Brown and my cousin Clint was in the Navy. And he came out of the Navy in 1955, and I went into the service. I went in as a gunnery officer on a destroyer out of Newport. At that time, Clint started building a 8-foot dinghy and a 15-foot runabout behind the house out in Seekonk, Mass. We lived in a 2-tenement house out there. Our fathers were brothers, and we were a pretty close family. We built an 8-foot and a 15-foot runabout, and Clint ran the business pretty much by himself from 1955 to 1957, and I got out of the Navy in 57, and we started our real business down in Bristol, Rhode Island, in 57. We operated down there building 15-foot runabouts, 8-foot dinghies, and a 16-foot runabout, and a 20-foot runabout. And we built the power boats until 1959. Those 2 years perhaps were I'd say those 2 years from 1957 to 1960 to 61 were perhaps the toughest part of it. You know, many people look back at us and say, you know, really, you hit the boat business at the right time. You really lucked out and you had it made. But at that time, we used to punch a time clock for kicks. And over 4 years, we averaged better than 93 hours a week. So we did put a lot of time in, and what we got out of it, we worked for. And it was a lot of work, but a lot of fun. In 1959, when we were building runabouts, that was really kind of a rat race. You'd build a boat that was being sold, you dealt with a group of dealers. The only thing I could compare it to was like selling used cars. And, you know, we had about as much money in our treasury those days as you have in yours. And it was a real chore to survive. In the spring of the year, you'd bang the boats out, and come fall, boy, you'd struggle till the boat show, and then you'd go through the cyclical pattern. And it was a lot of work and a lot of effort, and we really couldn't see the forest for the trees as to where we were really going. And then in 1958, in 1959, Tom Potter came to us with this plan of the boat that he had had Carl Wahlberg design. Tom had been with American Boat. Back in those days, American Boat were building the first of the Vitesse 40 yawls, which turned out to be the Block Island 40. Tom worked over there, and he had some ideas on a boat of his own, and had Carl Wahlberg had talked to him about designing and building the boat for him. Tom approached us, and when he walked in with a plan, we jumped at it and thought that this was a goal and something that would really be a challenge for us. I had been sailing, and Clint, I had my first boat when I was 8 years old. I had a square-ended punt that I sailed, and went from that to Beetles and Town Class and White Caps and up into S-boats, and had sailed all our lives, and we had the opportunity to build this boat. So it was in 1959 that we started with the Triton, put it in the show. I often think back, it was the week before the New York show, and it was in the fall of the year. Sales were always tough in the fall of the year in the powerboat end of the business. We were struggling to make ends meet. We had laid off most of the workforce. We were down to 6 people at one time. We got back up to 9 people just prior to the show. And I remember Joe Choate, who ran the New York show, called and told us we had to come up with the last $1,500 on our space. And we didn't have it. And I can remember charging all over Providence, going and visiting all the old Brown alumni who would patch on the back when I was playing football there, and come see me, son, anytime I can do something for you. Came up empty-handed, but it was a friend of the family, the funeral director. Went and saw him, and he slapped his bank book on the counter of the bank, and we borrowed $3,000. And from that, we were able to meet the last 2 payrolls and make the payment to get in the New York show. And that's how close your Triton came to almost perhaps not existing. But we went in the New York show in '59, and we came out. At that time, we were selling the boat direct. We did not have any dealers initially. It was a new product, and we came away with 18 deposits from that show. And we were able to go back and pay off the $3,000, which was a happy experience to really pay back a man that had some faith and some trust in us. But at that time, we then went into production of the sailboats, and finally sold out. The company just grew like topsy. I ran all the production end of the phase. My cousin Clint, who was a brilliant individual, he's a genuine promoter. He was charging and got the thing up and flying, and I ran production. Tom did a lot of development and sales work, and Fred Heel, another fellow, got involved in it. But the business grew like topsy, and we finally wound up short of capital. Had to sell out the Grumman aircraft. Clint stayed and decided he had enough of working for the big corporation, and he left in 1964. I left Grumman, as I was the general manager then, and stayed on until 1966. When Clint left in '64, he started what's now Bristol Yachts, and he and I had a falling out. We didn't see eye to eye in the philosophy of how to run a business or how the thing should be going, and so he went his way. I stayed on at Grumman, and decided I left in 1966 to start another business. I went into the industrial fiberglass business. So I had been in building mostly all forms of fiberglass products, from cooling tower fan blades to pollution control products to sewage components to the biggest part of it, cylindrical tanks, exotic fiberglass consoles. We work with a whole variety of fiberglass products. And along that time, we also went to Maine and built the tooling for a 58-footer for John Walden Company. And it was up there that I met Mr. Tillotson, and I formed a partnership with him and formed a new company, which we now call Tillotson Pearson. So the 2 Pearsons that originally started Pearson Yachts split. Clint is with Bristol, and I'm with Phillips and Pearson. It's a confusing thing, and today many people get us all fouled up and want to know who's doing what and where we are. The other point I think that when I was thinking as to what to talk to you folks about tonight, I thought maybe I ought to come here and give you the big pitch on the Freedom 40 that we're building now. Try to get you out of your Tritons into a new boat. It's about time. But we looked, and I thought back over, what is the in my opinion, what is the most significant thing that comes to mind about the Triton? I've had a lot of people accuse me of just building a lot of Clorox bottles that won't sink, and that we admit that we did put together a boat that we feel wouldn't sink. But when we started, back in those days, we had been building 15 and 16, 20-foot runabouts. When we first started building the Triton, the question was, how do you go about building that boat? No one in our organization had any experience in fiberglass or knew how to engineer a structure. I majored in economics, as Clint did at Brown. We didn't have an engineer working for us. We thought about this problem for a while, and about a year before that, on one Saturday afternoon, I was working down in the Constitution Street plant putting together some 8-foot dinghies, and a fellow walked through the door and came in and started to chat with me. It turned out his name was Preston L. Veltman, Dr. Veltman, and he was the head of research for the W.R. Grace Company. And Press Veltman just happened to come through the door, and we struck up a conversation, and he asked me what we were doing, and he took a fancy to what we were doing, and we had some correspondence, and he went back he lived in Savannah Park, Maryland, and I wrote to him, and he became my consultant father in solving and answering many of the questions and problems that we had regarding our fiberglass structures. At that time, Gibbs & Cox had not written a fiberglass manual. Fiberglass was still a relatively new product. You could not consult any textbook as to how to go about building the product. So we went to Carl Ahlberg, and I sat and discussed with him the loads that would be imposed upon a fiberglass boat. When the Triton plans originally came to us, they were wood plans. The boat was designed to be built in wood. And we wondered, whether we could make a hull laminate that would be comparable to the weight of wood. Would she float on her lines? Would she balance the same? So we had many unanswered questions. But when we started to loft the boat and get ready to build it, as soon as we had the plug done, I had talked to Dr. Veltman, and we decided the first thing to do would be to take sections of the boat that we considered to be critical structural points within the boat and some problems that would have to be solved in order for the boat to be structurally sound. Carl Wahlberg did the initial engineering, and he came up with the figures that he felt we had to be able to cope with, the loads that would be on the chain plate, the load that would be on the keel bolts, deck to hull joint, the racking motion of the coffee can on the lid. So we analyzed the boat as to where we thought the problems were, and the first one we thought of that we had to cope with was the laminating or tying in of the structural bulkheads within the boat. So after we had lofted it and built the wooden plug that represented the hull, I snapped a section off the side of the hull plug, and we made a section of a small, typical section of the mold. And within that, we laid up a section of what we thought would be a good fiberglass laminate, and we made up a series of, I think it was 6 or 8 sections of the hull composed of various structures of mat and roving, mat and cloth, and we took into that section, laminated in a typical bulkhead. And we tied in the bulkhead by putting different laminations bonding the plywood bulkhead onto the fiberglass structure itself. And we took all these sections and we sent them down to Press Veltman, and on Saturdays and nights, he and some friends of his took these sections into the Grace labs and loaded them. We bolted on a typical chain plate, and they pulled them for us. And on each sample that we submitted, we got back a report as to when it failed, what happened, where it started to delaminate, what the problems were. From that, they came and told us what they recommended. We made up new samples, sent them back to be evaluated, and from that, we arrived at a laminate that had approximately a 5-to-1 safety factor in holding the loads that Ahlberg had calculated for us. So we took the bulkhead structure, we solved that one. The next thing we did, we took the keel section of the boat, and we were concerned with bolting a lead on the outside of the hull. And when you bring a bolt up to a fiberglass laminate and back it up with a small washer, what happens when you fall off the top of a 20-foot sea and you come down and you get the inertia of that lead pulling down on the fiberglass. And it was really a concern. So we took and made sections of the hull, and we made a actual section of fiberglass. We had another small mold made, and we put typical laminates down into that section and sent those down to the lab. And they set that up in a machine, put a typical bolt in it, and pushed down on the fiberglass section until they heard and measured the deflection in it. And then they would push it through to ultimate failure when the whole laminate would rupture. And from those testing, we found that in order to handle the keel with a 5-to-1 safety factor, we were working to hang the keel on any one bolt with a 5-to-1 safety factor. We took, and you had to go and build up a substantial laminate in order to prevent the washer from being pushed down through the fiberglass. So Press Veltman suggested that we cast a washer that was thicker in the center and tape it to the sides, and we made those and put them in the bilge of the boat and put the keel bolt down on top of that so it spread the load across the bottom, and from that we were able to come up with a laminate that we could put the washer on top of and hold the entire keel on one boat with a 5-to-1 safety factor. We also took sections of the tow rail and the joint, and we twisted that for racking and determined at the proper laminate to have in the deck to hull joint. We took a section representing the stem of the boat and pulled on it as the stem fitting would pull to determine the shear load on the fiberglass, and we wound solving that just by increasing the plies of mat and roving. One of the interesting things we learned is that in putting a laminate together, if we took woven roving and put roving on roving, it would shear at about 1800 psi, and if we would put a mat in between, the shear strength psi in the laminate would jump to around 2400 psi. So we then decided that all our boats and all the structures would always be a mat roving laminate and never go to roving on roving. And it was interesting, in later years we built some boats for the Navy. We built 10 32-foot personnel boats and 33-foot personnel boats, and we built 40 32-foot patrol boats for the Coast Guard. And both the Navy and the Coast Guard in their laminates spec'd out roving on roving. And after we showed them our test results and pulled some samples for them, they finally came around to changing their specifications and went back to mat and roving laminates in the Navy specs. And it does significantly improve the structure of the boat. So we took and we did the rudder post. We checked that out. If there was a laminate, how to tie it into the hull. So we went through the boat, and basically the engineering that we did, I think to this day, proved to be extremely sound. The one thing that I can say and recognize, I have been accused, and a lot of people say that Pearson overbuilt their boats, and I think that perhaps we did. But I must say that when we overbuilt them, we knew what we were building to. And I counter that argument by saying I feel that many of the people that are building the boats today don't know what they're building them to. And one of the things that's really lacking in the fiberglass industry today is that there is no group, there's no Ralph Nader riding herd on the fiberglass industry. And the one thing that this industry is going to have before long is a Ralph Nader is going to rear his ugly head, and he's going to force the fiberglass manufacturers to know what they're doing and to be able to back up a boat. But unfortunately, in this economy of this country, price is the name of the game, and you don't sell unless you got the bottom dollar. And a lot of the manufacturers take it out of the laminate, and they're reaching the point right now so that it's a matter of conjecture. Many of the boats won't fail until they reach that ultimate point. Many people feel that you really don't have to design to that. I was at a meeting and was asked to be on a panel with one of the boat shows down in New York and discuss fiberglass laminates and what is required and what is necessary. And it's amazing. We sat around the table with 9 people from representing various companies in the boat business. And when I heard some of the arguments that were presented by some of the prominent designers, it shook me. They had a concept that you can't design a boat for the West Coast and West Coast conditions. And I said, well, how do you take that boat off Point Jude when it's blowing 35 and smacking into a southwester? Or if you come through the west end of the canal and you hit that southwester and you hit that chop, your boats wouldn't take it. And the argument is you're foolish to build a boat that way. You don't build automobiles, you build them for the terrain, you build things for what they should do. And we just couldn't buy that philosophy and never have. But consequently, when all the years that we were building boats at Pearson, I think one of the greatest satisfactions is the fact that we did not have any major structural failures to my knowledge. When we first started, one of the mistakes we did make, we started to make our own rigging, and we bought a sledging machine which was built by the United States Department of Mines. It was a company that built a sledging machine in which you put a shell, like a blank, and you put the sledge in, you fired off the cartridge, and the dies came down from the force of the cartridge going off, and it hit the Trulock and swedged it down. But unfortunately, when it swedged it down, it hit with such an impact it hardened steel and caused a hairline crack that was only visible from a microscope. And I think it was either the second or the third Triton, I never forget, we launched the thing on a Saturday afternoon, and the owners were there, and they christened the boat, and went down, and went off the dock, and set sail, and started going across the harbor, and all of a sudden the mast went down. And I nearly died, but and it turned out it was a broken Trulock, and we went back and had it analyzed, found out that the thing had cracked, went back and went to Kearney, bought a Kearney machine, solved that problem, and went on to our own rigging with a better machine. But overall, over the years, I have never found a boat to ever have bulkheads come loose. In the latter years, I built a 46-footer that we took and raced in the Southern Ocean Racing Circuit, and in Courtney Ross's yard in St. Petersburg, 1974, we had a race that was from St. Pete to Venice race. We hit winds of perhaps 35 knots, had a sea of maybe 8-10 foot short chop, and everybody finished the race and talking about how rough it was. And we got back to St. Petersburg, and I was asked by two designers to go up and help them solve a problem on their boats up at Ross's yard. And I get up there, and one boat was pushing the mast down through the keel, and the boat was a cord hull. It was laminate in all the core, and the bulkheads were coming loose. We looked that over and tried to help them with a solution. And there were 4 other production boats that were in there, had just finished the race, with the bulkheads the taping on the bulkheads were all loose. There were several boats built on the West Coast with the rudder posts out. And altogether, after that short race, there was, 8 or 9 boats that were in Ross's yard trying to be repaired. And his crew is going to take these boats and go around off the Keys and come up the Gulf Stream and you hit a northwest out there, can get pretty miserable. And why men would go to sea in those boats, I don't know what they do. And it really, it plagues you, and you really wonder. From that, I feel that sooner or later, people will probably reach the point where somebody will come up and set a standard, but it's a pretty difficult thing to try to reach the point where you feel a boat or laminate is satisfactory. One of the other points that came to mind on the Triton was we said, what happens if you run your boat aground and the tide goes out and she lays over on a rock or something? So we took and we designed the hull laminate up until the waterline, so you can take your Tritons, you can run them aground and let them go down on a rock, and we designed it so that a 1 square inch of area you can pull the boat up on. You can lay it right over on a keel and put it right down if you're below the waterline on 1 square inch of a rod, and we felt that she's liable to lay on a rock or anything hitting that point. And you'll get a deflection, I forget now, but it's somewhere like between 1/2 and 5/8 of an inch. The area will deflect if it's in between the bulkhead spans, and the boat will take the load, and you won't have any structural failure. From all this data that we had gathered on the Triton, I had a notebook, and it had all the charts, and they would send me up from the Grace lab a chart showing the scale readings and where things had deflected and all the writings on them, and I had this all in a notebook down the office at Constitution Street. And one day I had some men come in from Gibbs and Cox, and they wanted to talk to us about the boats we were building. And I sat down and naively opened the book and told them all the things we're doing and showed them the test data and pulled out the charts and the graphs. And they sat there and spent a day and a half with me going over this stuff. And as it turned out, if you take Gibbs and Cox manual today, you look in it and you'll see a Triton tow rail. You can see the Triton keel section, but there's no credit to Pearson Yachts anyplace for the data that was generated. And when I finally told Press Veltman, he blew his cock at me and told me I was an idiot and I should realize that I couldn't afford to pay for what I got for testing and engineering data with the value of net worth of our whole company. But over the years, it is what we did at those days proved to be, I think, extremely successful and satisfactory. One of the other interesting things we did at that time was a problem was with the gel coats on the boats. Back then, the gel coats, that the formulations they used did not have the flexible blends that they have in them today. Today they have a new chemical, NPG, neopentoglycol, which really helps the gel coat in its flexibility and its weathering characteristics. Back in those days, the gel coats tended to be brittle. We submitted to Press Veltman a whole series of gel coat samples, and we evaluated them, and they put them all through the weatherometer test down there, and we found that some of the Glidden initial gel coats, the metallics, would weather excellent, but the white gel coats were poor. So we went and we built our own Cowles mixer, and we bought titanium, and we bought an inert polyester resin, and we blended our own pigments and made our own gel coat, and we had a white gel coat that would outlast any on the market at that time, like 5-to-1 in a weatherometer test. So we had a few other things in the boat that worked out to be extremely sound and satisfactory. Over in one of the cases where the structure of the Triton showed up was in a storm in 1960 up in the Warren River. Eddie Thurston, the sailmaker, had a Triton, and it came ashore and landed up against the corner of a pier that was all solid granite blocks, and the boat sat there for 3 hours being pounded against the rocks, and finally it chafed through, and the boat sank right there. And after the storm, a crane picked it up and brought it in the shop and fiberglassed it up again, and the boat was fine. But it was amazing, the structure and the beating that the boat could take. So it's still a matter of conjecture. Perhaps we did overbuild them, but you can look back at it with satisfaction, and I assure you, as owners of them, maybe there's a lot of things wrong with the boat, but the one thing I think you can feel satisfaction is you know that when you go to sea in the boat, it's going to hang together. Other than that, over the last few years, we've gone into other things with boat. We've used some graphite fibers and 3 46-footers that we built. We have built in Maine, we built a 58-footer. We built that boat with a balsa cord laminate. We found that when we got into the larger structure, we took that boat, even when we had 1 3/4 laminate down in the turn of the bilge, when you went offshore at that length, you still got a racking and a twisting motion, and the only way to stiffen the hull was to go to a sandwich structure. And we went into end grain balsa on that boat, which served to give us a sandwich structure, stiffen the boat up, and it prevented any condensation from forming inside the hull. We got insulation from it, as well as stiffness. And so that we tend now to go to the balsa cord laminates on any of the bigger boats. Although we're building the Etchell 22, the little racing 30-foot racing boat. We built several hundred of those. That's a solid fiberglass laminate. We're now building a little 24-footer in which we're using a 3/8 balsa sandwich on the structure of the hull to make it light and fast. But the overall structures still go back, and we still use the guidelines that we developed back in the days of the Triton, and it served us well not only in the boat business, but we used a lot of the knowledge that we gained there in the industrial end of the business as well. We have a shop now in Warren, Rhode Island. We do all the molding there, and we do the finishing of the boats in Fall River. We have 140 people working. We have 85 glassmen who work with 13 different kinds of resins, building a variety of products. We recently were picked by the state of Rhode Island with Hawkins and Fales down at Bristol to develop a 30-acre site down in Narragansett Bay where we hope to put in a marina as soon as we can get our permit from the Corps of Army Engineers. That's the last stumbling block now, and to move a whole boat building facility down into that area of the bay. But that's the a little bit of I don't want to go on and bore you with a lot of boring details. That's the story as far as the production end of some of the highlights of the flight. Maybe I'd be happy to answer any questions that you people may want to ask about it. I have had my nose in those boats. I did everything on the first boat, from laying up the decks and the hulls, installed the engines, so there wasn't much about the boat that I didn't understand.
When you went down to that first boat show with the borrowed money, you had made just one Triton and took it with you.
That's right. It wasn't finished either. We had worked for 3 straight days prior to that show. There was a fellow named Ollie Bowen, myself, and 3 men. We slept in the boat, worked in the boat, but we went around the clock for like 3.5 days in that boat, trying to finish it off for the New York Boat Show. And it was pretty crude when we got it down there. And the engine was in, but we didn't have time to get it wired. And we were apologizing for a lot of aspects of the boat. But we got it there. We loaded it at 2 o'clock in the morning, and we hand-jacked it up, got it on a truck, got on that truck and rode it to New York and got it in the show, and then went to sleep.
Another question. I think it's 491. I was wondering how many changes you made until you got to a point like that. Did you make a lot of changes?
The basic changes that were made in the boats, the laminate, the fiberglass structure stayed identical. And as far as I know, the laminate of the hull, we did not change at all. When we first started to build the boat, we had a lead on the outside of the hull. And we did that because in the back, first of all, we did it because we couldn't have a split mold. We were doing it in a mill on Burnside Street. It was an old textile mill, and there wasn't enough space between the posts to split the mold. So the mold had to stay together in one piece. But back in the stern section, down at the foot of the skeg, she was so narrow that we couldn't get down there. It was our first attempt at building a boat of that size. We felt we could not get a satisfactory laminate down to the area of the rudder shoe. So we took and chopped out the hull there, made a second molding, and installed that under the hull down by the rudder shoe into the lead. And that was used up until, I don't know now, the records would be down at Pearson, but we then eventually went to a new mold and put an internal lead ballast, and we put the lead inside the laminate. So we increased the depth of the boat, I think about 1.5 inches, so that the position of the lead stayed identical. Other than that, the major changes in the boat were cosmetic. We put a headliner in so that the boat would have a better looking interior. We changed from the rubber ports. We didn't. No one had patterns to put windows in it. It was too expensive to go out and get the patterns. So we put rubber gasketing around the initial windows and eventually changed that over to casting. And one of the problems that confronted us back in those days, none of the suppliers in the boat business were ready for mass-produced boats. I was telling Bill earlier, when we first started, it was either 1961 or 62, we bought out the entire production of Wilcox Crittenden, Rostan, and Merriman, all the turnbuckles that they would sell us. And if you don't think that creates a nightmare, if you take those 3 turnbuckles and extend them, they all had different length bodies. So we had to adjust the lengths of rigging to go with each turnbuckle that was going out with the boats, and try to keep a record of them so that if people had a problem, we knew what length shrouds were going out. But none of the production facilities were geared up for the kind of volume of parts that we were ordering. They couldn't understand, where all the parts were going. But that was amazing how the industry started to mature as it went along. See, back in those days, you were building the Block Island 40. The Bounty operation was a big boat being built by Coleman on the West Coast, which we eventually, that was Aero Marine Plastics, and we bought that company out. And we bought out the Bounty and brought it to the East Coast and called it the Rhodes 41. We operated in Sausalito, California. We operated the plant there for 2 years, but they were highly unionized. And within that plant, a fiberglass man did nothing but fiberglass work. The carpenter couldn't pick up a fiberglass brush. The electrician couldn't do any mechanical work. And we wound up being able to build an Allbird 35, for instance, cheaper in Bristol, ship it to the West Coast, and have it there cheaper than we could build them there. And we were forced to close down that plant. But we had the plant there, and then we, later on, were about ready to open a plant in Texas. many complaints. Everybody used to complain that when their port was laying back like that, they trapped water, and every time they opened up, the water poured in on them. And we got nothing but grief from them. So the easiest way to solve the problem is forget them.
That's a good point.
That was offered as an option, though. We took it off as standard, and you could get them if you wanted it. No, it was just to get a little more headroom in it. Can't answer that. I can't remember. But I know that we had a lot of people like one thing when you start building a boat, you know, whether you make the berth 6'2" or 6'4", then someone wants it 6'6", and the same thing with headroom. And, you can never satisfy anybody, but the complaint was that we did have to have more headroom, so we did raise a little bit. Yep. None whatsoever. There's no problem that all that the washers that are used were bronze with a stainless steel bolt, and in all the testing that was done before we put those in, there's no problem that we can foresee in that area. And I think that if you took it apart, you'd find it just as good today as when it was installed. But they are fiberglass over. I don't know. We were still building them when I left in 1966. 7-Eleven. I would have to go back to Pearson Yachts and check the records.
Were the West Coast boats numbered and within the same series of the East Coast, or were they two different sets?
No, we allotted a block of numbers for the West Coast. That could have been in Sausalito. Just ran out of a sale. You can see the next thing that happened was the boat that put the Triton out of business was the Cal boat. The Cal boat came in from California, and they came out with this beast. I can remember the first time I saw it at the New York show. I couldn't imagine anybody buying this boat because she came up to the sheer, and then the deck went right up straight again, and then she went across. And went down below in that boat, and, you know, it was like a ballroom inside. And that boat started to sell like topsy, and the sails of the Triton just started to fall right off. And, you know, it was flush deck out, and that was the advent of the whole style changing of the boat. It was like a West Coast concept. 2 or 3 of the builders out there had going back to an old, like a medium Dutch stone horse, and raised the deck out, and they took advantage of the space below and started the whole trend going. And as soon as people, that changed the whole philosophy. Instead of a good, sound sailing boat, the philosophy went to just to please the woman. You know, and you were just, and the whole concept on the West Coast was just to make them look pretty and
Ed, I think you're on dangerous ground in pleasing the woman. If I move away from that, back to, you were talking about the experience with this glass laminated with end-grain ball holes. And you didn't mention Eric's foam, which is not a Triton story. But what's your feeling about Eric's foam versus end-grain ball holes?
yeah, I have definite opinions about it, and my opinions are based upon a whole series of tests that I ran between Arex laminates and balsa laminates. When we were going to build a 46-footer to try to build a real lightweight racing machine, we ran it for 25, 30 panels with laminates, and Arex wanted us to build the hull with Arex. Balsa people wanted the balsa. So we took and made a whole series of tests. The Arex foam is a perfectly satisfactory core material, except for one thing: you cannot get a stiff laminate with it that you can get with balsa. The balsa laminate, for the same weight, will run about 1.6 to 1.8 times stiffer than an Arex laminate. The second problem with an Arex laminate is that the PVC foam is attacked by the styrene monomer in the polyester resin. And when you start working with bigger structures, you have to put that laminate down and kick over your resin fast enough so that it gels prior to attacking and plasticizing that PVC foam. The other thing is that we built a few Etchells 22s, and we used some Arex foam in the deck. And one day I had one sitting out in the yard in the sun with a 5-gallon bucket of gel coat on the deck, and all of a sudden I looked out, and half the bucket of gel coat was not visible. and just in the heat of the sun and the weight on it, the Air-X foam will flow. You can compress it to 50% of its value, and it will recover. Now, at times, that's good if you can impact the hull and you do not lose the structural bond between your fiberglass and the Air-X. But my feeling is if you're going to go to a cord laminate, you're going there to get stiffness. And if you want stiffness, the way to get it is with end-grain balsa. Now, and that'll prove out in tests weight for weight. Up until the last couple of years, many people were afraid of balsa wood. Balsa wood, when it used to be used, was long grain. When the water would travel, we used to lay it in flat pieces. The water would travel up to a piece of balsa wood by capillary action. After a few years, Bob Levine and Alex LePay, two engineers at Balsa, Ecuador, took the suggestions we had of laminating the balsa wood together, sliced it this way, and then bonded it onto a fiberglass scrim and come out with what they now call contour core. And so that when you take a fiberglass laminate with the end grain balsa, each little block of balsa wood, if you put resin on it, and this was just Lloyd's of London published a report in about a year ago in which they have taken a whole series of panels of end grain balsa, put a hole saw right through it, left the balsa wood open, submerged it at 30 psi, and after 1 month, the migration of the water into the balsa wood was less than 1/8 of an inch. The water will not go. The grain is running this way, and if you put balsa down satisfactorily, you've got a good laminate. That's the next problem, to put balsa in a laminate satisfactorily. If you take your typical production shop and let them start throwing balsa in them, you've got to know what you're doing. And if they don't get the balsa pressed down into the laminate, and you get an air pocket under it, whether you've got Air-X or whether you've got balsa core or honeycomb or Strux or CCA, any foam or any core material, it's going to fail. So what we do when we put balsa on the big boat, we vacuum bag it. We actually seal all the way around the balsa wood, and we put a PVA film over the entire thing. We lay a piece of hemp in back and forth under the PVA film to act as a bleeder, and we put a vacuum hose under the PVA film and suck the air out and let that bag push the balsa wood right down into the laminate, so that we're sure of getting a satisfactory bond with the balsa wood. The Triton, when we first came out, was all long leaf. What? Yeah, on the decks of the Triton. One of the first problems, that was a major problem. Bill asked me earlier, what would you do if you were going to buy a Triton? What would you look at for problem areas? And one of the things was, when you build a hole through the deck on the Triton, we used to have a caulking gun who would put a slug of resin, filled resin, around the bolt hole to prevent water going through the deck traveling into the wood, because it would get into that strip of balsa wood and turn it mushy. But if you take, and then you had to cut out onto the deck, and we used to patch it by filling it with microblue.
You changed that.
We changed that into end grain.
Mine's 551, and I'm in.
Right. Well, the balsa, that was because of the problem that we were having, that the balsa engineers agreed to go back and do some work and change it, and it's a far better product. So Air-X versus, there's still people that Ted Hood still builds his boats with Air-X. If you go down and look at the Robin, the 2-tonner he had in Newport, and where the chain plates go through, they fold it up, and you can see the laminate compressing. And there's no way you can stop it. It's just going to compress. So I think it's a personal preference, and you can argue both ways. We have our opinions, and we run our own tests to back it up.
I'm curious, in Stem and Stern, where your stem fitting and stern, your chain plate come in, you've got a long tubular pipe-like structure. Is that simply a layup of fiberglass with persistent beaten up on it?
It's just a structural member, and there's a piece of wood in there, and you can take the wood and let it rot out, and there's enough structure in the glass covering it so that the glass will take the load. But the wood was just simply in there as a forming member. And the chain plate, we put it out and up in the stem of the solid. It's on the tabbing that came off the bulkhead. It's an extra laminate of fiberglass that attached the bulkhead in, and that piece landed on top of that. And when you take and then there's some screws that go into it. But when you take and load that on that tabbing, it's more than enough to take the load of the spot. The problem there, on some of them, if the carpenters did a lousy job, it didn't fit it up tight enough, it allowed the deck beam to come down and whisk it till it made up. That was one of the problems we had on the Allbird 35 when they fit the beam in. If the men doing the work left a void there, it would come down until things tightened up, and then it didn't move anymore. But it was a workman quality problem on our part, that not fitting it up. But if it was done and put installed and set it up there properly, it didn't move.
How about problems with cracking that texture? Who made the truck load? Carried on that. You don't see mine could fly. I heard you put sister in with a little place behind the other.
See, just the way Carl Allbird designed it. We sailed the first boat, and they're all, the mast stayed in the same position. Cal 26 or Cal 28. I don't know, there's been so many of them over the years, but, it's just, it had no shape. No, it was not seaworthy, and it's one of the... Right, but it was one of the boats that I picked apart. I did some work for the insurance companies over in Hartford. There was a group of insurance companies, and I went over and did some work with their adjusters, showing them laminates, how to evaluate laminates, and checking them out and so forth. Showed them a lot of the test data that we've done, and gave them an educational course in fiberglass. One of the problems years ago in insuring the fiberglass boats was an adjuster had no knowledge as to how to go about whether, analyzing a boat and finding out whether it was satisfactorily built or not. All we did was go over and explain to them why we built the boat the way we did, and try to explain to them how you could go into a boat and analyze it and to find out whether the boat was structurally sound. And it's very difficult to do. Sometimes you have to pull out some panels in the boat and there's decorative coverings that are in there to really load a laminate to find out whether the boat is satisfactory or not. And some of those boats that were built on the West Coast were junk. As I used to say, they'll break up before they get to point two. But most of the time, you've got to remember that people don't drive a boat hard. When you get offshore, I've been on a lot of boats. And when the things start to work, people chicken out, and you'll ease off the sea. And you'll try to either run with it or you'll baby the boat. When I sailed, I raced on a boat off when we almost put a water tank through the front of the hull off Block Island. And you see this thing, and you watch these hulls go, and in this case, we had to ease off. We could not race the boat hard. If we raced the boat hard, we would have sunk her. Because when we came in, we had gone through most of the laminates. The gel coat was knocked off the outside of the hull, and the water tank was banging right against it. The hull was moving, really panting badly. I won't say. Because, there's a lot of things you can say about it, but we brought it in. We got the people that built the boat to come take a look at it, and whether they do anything about it or not, I don't know. But, it does, I wouldn't want to be halfway to Bermuda and see it happen.
Did you say you started selling it?
Yeah, Walter Doe and Teague, the industrial designer, took his Triton and sealed off the openings in the front of the cockpit. He sailed his boat to Bermuda. That was back in really 1960, 61. Souffle.
Now named O'Reilly.
All right. He sealed off the ice box floating. No, we had openings underneath the cockpit seat. There were some flaps that were in there, boxes in there, and he sealed those off when he went offshore. Yeah, that ice box, the bridge deck ice box floating on the initial boat was a terrific idea, except the insulation wasn't good enough. Piece of plywood in there. There was a big elbow problem. It was a matter of dollars. Everybody thought it was much cheaper, much less expensive. Yeah, well, at times. And other times, some of the prices they were getting for them were as much, if not more. And we had a boat at Hawkinson Fails a year and a half ago. Tried to lift the boat out with a travel lift, and the travel lift slings were coming up. They're coming up, and the boat's not coming out of the water. We went aboard, and the port timbers are all coming up, and the actual, when she went down like that, the keel was coming up into the boat. And he couldn't haul her. Had to with a travel. We'll put her back in the water. And that boat is built by a quality fiberglass manufacturer in Florida with a big name and the whole bit. Yeah, you could roll it over, you know, it'll come back up in any way. But I don't know, right, you know, she's a good sound design, and she had nothing flaky in her, you know, she wasn't eccentric in any way. Oh. I don't know.
Well, ask Bill Bell that question. He felt this is rail down. It's hard to get the rail pretty far under.
Yeah, you've got to work like a dog to get that rail down. You get it down, and it's just dumping wind.
It sounds so far, and
But
it's very
he's fine.
stiff.
Yeah, I fill with a whole load of 25, and it's very hard. It's reasonably calm water. But I think, isn't the correct answer the maximum riding moment is going to be when you're over 90 degrees? Because the keel is off, you've got the maximum lever arm. So you've got to go at Sand Hill to get past 30, 35.
I would say the optimum would be probably between 15 and 18 degrees. 18, yeah. No, most boats, I would say mostly all boats, if you get over 22 degrees, you'll find your wetted surface is increasing and that the boat is starting to slow down. But most people, you'll find that if you can bring yourself to take the sail and shorten sail, it's going faster. But it takes a long time to prove that point. Yes. The boat, the problem in the ensign is holding when we put the number 1 Genoa on the ensign, the panel of the mast at the spreaders was kicking ass. We couldn't hold the mast straight. So we had to put forward lowers on it.